Welcome to Professional SQL Server Integration Services course. Before we dive into the details of how to use SSIS, let me give you some introduction on what SSIS is and what you can expect from this course. The one consistent skill needed in today's technical job market is ETL, that is extract, transform, and load. Let's say your company wants to establish a partnership with another company. They'll need to communicate data back and forth between the two companies. If your company wants to launch new products, they'll need a way to integrate these products into their website and catalogs. All of these types of tasks are going to require the skill set you will learn in this course. Some of you may be new to SSIS. If so, you've picked a fantastic field to become involved in. Companies that had never used SQL Server before are now allowing it in their environment because SSIS is such an easy-to-use and cost-effective way to move data. SQL Server 2014 now offers more components that you can use to make your life even easier. This course is intended for developers, DBAs, and casual users who hope to use SSIS for transforming data, creating a workflow, or even maintaining their SQL Server. This course assumes that you know the basics of how to query a SQL Server and have some basic programming skills. By the time you've completed this course, you'll know how to load and synchronize database systems using SSIS by using some of the new SQL Server 2014 features. So, let's dive in and see what this course has to offer. The first module introduces the concepts that we're going to discuss throughout the remainder of this course. We will talk about the SSIS architecture and give a brief overview of what you can do with SSIS. We will discuss the different elements of SSIS, how to install SSIS and the sample database, and then we will explore the different tools that SQL has to offer for the data transformations that we will be doing. And lastly, we will learn how to upgrade existing SSIS packages. So, let's get started. SQL Server Integration Services was released to the market in SQL Server 2005 and took the ETL market by surprise. In SQL Server 2008, SSIS has focused on maturing the product and improving the product's scalability and performance. SSIS is an enterprise-level extract, transform, and load development tool. However, SSIS is not just a fancy wrapper around an export-import wizard. It is a platform for building high-performance data integration and workflow solutions, including the ETL operations for data warehousing. SSIS includes the graphical tools and wizards that you'll need for building and debugging packages, along with the tasks for performing workflow functions such as FTP operations to copy, move, or delete the files, and it can be used for executing the T-SQL statements and sending out email messages. SSIS also includes data sources and destinations for extracting and loading data, along with transformations for cleaning, aggregating, merging, and copying data from one place to the other. Let's first see how to use the import-export wizard, and then we can see how much more SSIS can do. If you need to move data quickly from almost any data source to a destination, you can use the SSIS import and export wizard. This wizard is a quick way to move the data and perform very light data transformations such as casting of the data into new data types. You can quickly check any table you want to transfer as well as write a query against the data to retrieve only a selective amount of data that you want to transfer. There are different ways to start the import-export wizard. You can right-click the database you want to import the data from or export the data to in SQL Server Management Studio and select Tasks, and then select the Import Data submenu. Or you can right-click the SSIS packages in SQL Server Data Tools and select the SSIS Import and Export wizard. Another way to start the Import and Export wizard is by using the Start menu under SQL Server 2014 and choosing the Import and Export Data menu. You can also start the same wizard by typing dtswizard.exe at the command line or at the run prompt. This wizard uses SSIS as framework and can optionally save a package as its output prior to executing it. The package it produces will not be the most elegant, but it can take a lot of the grunt work out of package development and provide the building blocks that are necessary for you to build the remainder of the package. Oftentimes, as an SSIS developer, you'll want to relegate the grunt work and heavy lifting to the wizard and do the more complex coding yourself. The wizard does no transformations or cleansing, but instead only moves data from point A to point B. Now let's see how to transfer data from point A to point B using the import and export wizard. Let's expand the AdventureWorks 2014 database. Let's look at the tables, and let's say you want to transfer the employee table data from the AdventureWorks database to the test database. Let's open the wizard by clicking on the AdventureWorks 2014 database, go to Tasks, and click on the Export Data. Once the wizard comes up, you see the typical Microsoft Welcome screen. Click on Next to begin specifying the source connection. Let's click on Next. And since we have opened the wizard from Management Studio by selecting the Export Data option, this screen is pre-populated. In this screen, you specify where your data is coming from in the Source drop-down box. Once you select the source, the rest of the options on the dialog box may vary based on the type of connection. Let's change the data source to Microsoft Excel, and you can see it asks for the file path and the Excel version. Let's go back to mentioning the data source as SQL Server. For SQL Server, you must enter the server name and the username and password you want to use. If you're going to connect with your Windows account, simply select Use Windows Authentication. Windows Authentication will pass your Windows local or domain credentials into the data source. Let's click on Next and specify the destination. Let's click on SQL Server as the destination and then mention the server name and the database name. As you can see, the properties for this screen are exactly identical to those in the previous screen. The only exception is the database. Let's click on Next and select which option to use to transfer the data. In this screen, if you select the Copy Data from one or more tables or views option, you can simply check the tables you want and transfer the data. Instead, if you select the Write a Query to specify the data to transfer option, you can write an ad hoc query, or you can select which stored procedure to use to retrieve your data. Let's click on Next and specify which table data you want to transfer. Let's click on the Employee table and click on the Edit Mappings button to go to the Column Mappings. Here, you can change the mappings between each source and destination column. Let's say you don't want the business entity ID in the destination table. You can simply do that by clicking on the drop-down and choosing Ignore. By checking the Enabled Identity Insert box, you allow the wizard to insert into a column that has an identity value assigned. If the data types don't match between the source and destination columns, the wizard will add the necessary components to convert the data to a proper data type if possible. In this instance, since the destination table doesn't exist, the wizard automatically selected the Create Destination Table option. Let's uncheck the Enable Identity Insert and then map the business entity ID in the source to the same column name in the destination. But if the destination table already exists, you have the option to delete the rows or append the rows to the destination table, or even drop and recreate the destination table. Let's click on OK and click on Next. This screen enables you to save the package or just choose to run it immediately. You can uncheck the Run Immediately and save the SSIS package to run it later on. You can open this package using the SQL Server data tools if you'd like. You can do this by creating a project in SSDT and adding the package to the project. You cannot edit the package without an SSDT project to contain the package. We will discuss how to create a project later on in this course. For now, let's select Run Immediately and click on Next. This screen shows the actions that will be performed when you click on Finish, and the next screen executes the process and shows you the output log. Let's click on Finish. As you can see, it shows the output and says that 290 rows were transferred to the destination table. Let's click on Close and go to the destination database, which is the test database. Let's click on Refresh, expand the database, go to Tables, and let's select the Employee table and click on Script Table As, select to New Query Editor window. Let's click on Execute, and as you can see, the 290 rows are now available in the destination table. So, now that we have seen how to use the Import and Export Data wizard to transfer data from point A to point B, let's see how to install SSIS. When you're installing SQL Server, you need to ensure that the SQL Server Data Tools, Integration Services, and Management Tools, the complete checkboxes are selected in the Feature Selection screen. The Integration Services option installs the runtime and the service necessary to run the packages and is likely all you would need on a production server. The SQL Server Data Tools option installs the Designer components, and the Management Tools option installs the DBA tools necessary to manage the packages later. After you complete the Features Selection screen, SQL Server installs all the necessary components without any wizard configuration required for the SSIS. And once the installation is complete, open the configuration file. Let's do that by going into C, Program Files, Microsoft SQL Server 120, DTS, bin, and open the msdtsserver.ini XML file. You can change the server name node from a dot to your SQL Server's instance name where you want to store your packages. You can also change the directory from packages to the directory of your choice. Once you modify this file, you need to restart the SSIS service from the SQL Server Configuration Manager under the SQL Server 2014 node in the Start menu or the Services applet. Now that we have learned how to install SSIS and also how to change the configuration file for SSIS, let's see how to install the sample database that you'll need for the tutorials in this course. Let's close this file and see how to install the sample database. The sample database is not installed by default with the SQL Server 2014 installation. You can download the sample databases from the internet and then install them. To use the AdventureWorks 2014 database, you must enable the full text search feature and enable the file stream feature in SQL Server 2014. The file stream feature enables you to store files quickly and easily on the file system of the server, but they are treated like columns in a table. When you back up the database, it also backs up all the files to which the tables may refer. This feature is initially enabled in the installation wizard, but you can also enable it after the installation using the SQL Server Configuration Manager under the SQL Server 2014 Configuration Tools. Once the Configuration Manager is open, double-click the SQL Server database instance on which you want to enable the feature, and this opens up the properties of the service where you can go to the File Stream tab to enable the feature. Let's see how to do that. Let's go to the Configuration Manager and click on the instance that you want to enable that feature on, and then select the File Stream tab and enable the feature. Click on Apply, and once these changes are done, you need to restart the instance. Click on Restart, and it may take a while to restart the service. And to install the sample database, you first need to download it from the internet. And as you can see, I've already have the backup file for AdventureWorks 2014. Now let's see how to install this using the backup file. Let's go to Management Studio and right-click on the database and click on Restore Database. Let's select Device, click on Add, and select the file that you want to restore and click on OK. Now let's click on OK and change the name for this new database to AdventureWorks 2014_test, since I have already installed AdventureWorks 2014 database. Click on OK. It may take a couple of minutes to restore this database. Click on OK, and as you can see, the AdventureWorks 2014 test database is installed. Let's go to Tables, and you can see all the tables and the views and the related stored procedures. Now that we have seen how to install a sample database, let's see how to create an SSIS package. You cannot create an SSIS package in SQL Server Data Tools without first having a solution and project. Additionally, for execution of the package in debug mode, which you will use when troubleshooting, your package must be in a project and a solution. Projects and solutions are containers for your packages that help you keep every component together and make you a more efficient SSIS developer. SQL Server Data Tools is the program in which you're going to develop your SSIS packages. In SQL Server 2014, SSDT is a Visual Studio shell. You can either open SSDT by itself under the SQL Server 2014 program, or open it by opening the full Visual Studio program. An SSIS project is a container of one or more packages and other SSIS components. And a solution is a container of one or more projects. Solutions enable many types of projects to live under one container. When you create a project in SSDT, a solution is automatically created at the same time. Let's see how to create a project and a solution. Let's go to the Start menu and click on SQL Server Data Tools. Go to File, click on New and Project. Let's select Integration Services Project and change the name to My First SSIS Package. Click on OK. And as you can see, a package has been created. And as you can see, this is the first package name. At first, the solution will not appear in your Solution Explorer because you have only a single project. Once you add a second project, it will appear. You can add subsequent projects into the same solution by going back to File, New Project, and clicking on Add to Solution. And let's select Integration Services Project, and let's call the package or project as My Second SSIS Package. Click on OK. And as you can see, two projects are added under the same solution. And the solution that both these projects are added to also appears in the Solution Explorer. You can choose to always see the solution file in the Solution Explorer by going to Tools, Options, and under the Projects and Solutions General tab, select Always Show Solution option and click on OK. Now that we have seen how to create a solution and a project, let's see what tools SSIS has to offer. SQL Server Data Tools is a Visual Studio tool that helps you create, debug, and execute SSIS packages. When you are a business intelligence developer, SSDT can also help you create reports using the SQL Server Reporting Services or design cubes in SQL Server Analysis Services. Since we have created a project already, let's explore the environment. The most important pane, which is the Solution Explorer, is on the right. The Solution Explorer is where you can find all of your created SSIS packages, shared connection managers, and parameters. Like we discussed earlier, a solution is a container that holds a series of projects. Each project holds a myriad of objects for whatever type of project you're working on. For SSIS, it holds your packages, shared parameters, and shared connections. And once you create a solution, you can store many projects inside of it. For example, You might have a solution that has your VB.NET application and all the SSIS packages that support that application. In this case, you'd probably have two projects, one for VB and another for SSIS. After creating a new project, your Solution Explorer window contains a series of empty folders and a single package in the Packages folder. For example, in this screen that you see here, you see a solution named My First SSIS Package, and underneath it there is a project called My First SSIS Package. And inside the project, you can see a default package by the name of package.dtsx. If you look into the directory that contains your solution and project files, you can see all the files that are represented in the Solution Explorer window. Let's go to Tools and click on Options and find the location of your projects and solutions. Let's copy it and open a File Explorer. Go to that location. As you can see, there is a folder called My First SSIS Package, which is the name of the solution. Let's open that folder, and now you can see two folders, one each for the projects that are underneath the solution. And as you can see, you can also find a .sln file, which is a solution file that contains one or more projects. Let's open one of these folders, and you will find different kinds of files underneath each of these folders. This file here is an SSIS project file. The .params file is a shared parameter file. And the package file that you see here is a .dtsx file, which is an SSIS package file. If we have defined a connection manager and a data source, we would have seen two different files here with the extension of .ds, which is a shared data source file, and a connection manager, which is a shared connection manager file. Now that we have discussed the different kinds of files that make up a solution, project, and a package, let's discuss the different deployment models that SQL Server 2014 has to offer. In SQL Server 2014, you have two models for developing and deploying packages, package and project deployment models. The package deployment model used to be the only deployment model that existed in SQL Server 2005 and 2008. And this deployment model only allows you to deploy only a package at a time to the server. It also has ways of configuring the packages to change properties like connections with XML files or tables. SQL Server 2012 introduced a new deployment model called the project deployment model. Using this, you can only deploy the entire project of packages, and packages can be configured by the database administrator through parameters. And now that you have two deployment models, you can switch back and forth between these models. But the new project deployment model is much more robust with features. You can switch back and forth between the models by right-clicking on the projects in the Solution Explorer and selecting Convert to Project or Package Deployment Model. Let's close this and select a package and go to Convert to Package Deployment Model and click on OK to convert it to the Package Deployment Model. Click on OK. And now this package will be deployed using the package deployment model. Now that we've learned about the different deployment models, let's learn about the Properties window. The Properties window is where you can customize almost any item that you have selected. To explore the Properties window, let's add a task to the control flow, right-click, and select Properties. Let's expand this. And as you can see, you can configure pretty much everything that is related to that task using this Properties window. You can change the description or the name of the task, and also customize the maximum error count because it's a data flow task, and many other parameters. The view of this Properties window also depends on what kind of task you have selected. You can also click the white background of the Control Flow tab to see the package properties in the Properties window. Sometimes you can see more advanced properties in the Properties pane than what the Task Editor's user interface provides you. And as you can see, the properties that are displayed when I select the data flow task are different from when I select the white background in the control flow tab. Now that we've learned about the properties window, let's explore the toolbox. Let's close the properties window. And as you can see, the toolbox contains all the items that you can use in the particular tab's design pane at any given point of time. For example, the control flow tab has a list of tasks and containers, and this list may vary depending on the number of custom tasks that you have installed. And the list of tasks that you see in the toolbox will be completely different when you are in a different tab, such as the data flow tab. Let's go to the data flow tab, and as you can see, the toolbox has a different set of tasks. And the toolbox is organized into sections called Common, Containers, and Other Tasks. And these sections can be expanded or collapsed for usability. And as you're using the toolbox, if you find that you're using one of the tasks more frequently, you can add it to the favorites by right-clicking on it and clicking on Move to Favorites. And as you can see, the data profiling task is now under the Favorite section. Also, after you install a custom component, it automatically shows up in your toolbox. When you select a component like a task from the toolbox, you can notice that in this pane here, it shows up with interactive help with find samples and a short description of what the task does. Now that we've discussed briefly about the toolbox, let's look at the SSDT design environment itself. The SSDT environment contains two key tabs for designing the packages: Control Flow and the Data Flow. Each of these tabs handles different parts of your packages. The Control Flow tab controls the execution of the package, and the Data Flow tab handles the movement of the data. The Control Flow tab defines the execution of your package, dictating that one task, such as an FTP task, should execute ahead of another, for example, an execute SQL task. Inside the tab are tasks and containers you can drag over from the toolbox onto the design pane. And each of those tasks has its own user interface that you can use to configure the tasks, and you can access it by double-clicking the component. Each package has only a single control flow but can have many data flows. The user interface for the data flow task is quite different. Its user interface is the Data Flow tab. In the Data Flow tab, you can configure one or more data flow tasks by dragging sources, transforms, and destinations onto the design pane. Like we discussed earlier, each control flow can have any number of data flow tasks, each of which results in a new item in the Data Flow tab's drop-down list of tasks. Let's go back to the control flow and add one more data flow task, and then go into the Data Flow tab. Now click on the drop-down, and you can see two items in this drop-down list. The data flow is essentially where you're going to configure the movement of your data from nearly any source to nearly any destination. Now let's see how to execute a package. Let's select the package that you want to execute and right-click and click on Execute Package. As you can see, there is a Progress tab that appears. When you execute a package, you go into the debug mode, and this Progress tab is where you go to debug when a package has a problem. You can also go to the output window, which is seen in the window below, to debug the package. This output window displays a textual view of the same Progress tab. Let's go to the Progress tab and see what information it has for us. The Progress tab displays the execution results of the package that is being executed. It displays that a particular task has started and finished, and also displays if there are any warnings or errors. You can stop the debug mode by going into Debug and click on the Stop Debugging, or you can simply select the Stop Debugging button, which is displayed. Click on Stop Debugging, and as you can see, the Progress tab is now converted into Execution Results tab. The Execution Results tab shows the last run of a package. Each of those tabs show you more than the output window at the bottom. One other handy thing you can do from within SSDT is to open the Server Explorer. Server Explorer enables you to create a connection to a SQL Server database that you can manage just as you would in Management Studio. You can do this by selecting Tools and connecting to a database of your choice. All you need to do is type in the credentials for the database that you want to manage, and then you're ready to run queries against the database, create stored procedures, or redesign tables. Now that you have taken a look at the SSDT environment, let's see how to create your first package. Creating packages in SSIS involves dragging various tasks over, configuring the tasks, chaining them together, and then executing the package. Let's learn how to create your first SSIS package. To create a package, you'll need an SSIS project. Since we have already defined a solution and a project, let's add a package to an existing project. Let's cancel out of this. Since the default package is already available, let's rename it by right-clicking on it and clicking on Rename, and rename it to Simple Package. And let's leave the .dts extension in there. Another way to add an SSIS package to an existing project is by right-clicking on the SSIS packages and clicking on New SSIS Package, and it will come up with the name package1.dtsx. And you can rename this package in a similar way that we did for the simple package.dtsx. To design a package, you want to first create connections, which are called connection managers in SSIS. A connection manager is a connection that can be leveraged and consumed once or many times in a package. To create a connection manager, right-click in the Connection Manager pane at the bottom of the screen in SSDT and select New and define the type of connection. Let's right-click in the Connection Managers pane, and as you can see, you'll find some most commonly used items in this list. If you want to access all kinds of connections that are available for SSIS, you can click on New Connection, and it displays all kinds of connection managers that are available. The handy thing about connection managers is that they are externally available to a DBA at runtime. In other words, when a DBA goes to schedule this package, he or she can point the connection to a new database or file on the fly for that one job. Once you create an OLEDB connection, it is available to you anywhere in the package from any component that can use this connection. And if you want to create a connection that can be leveraged from multiple packages within the solution, you can do that by creating a project connection manager. To do that, let's first cancel out of this. Right-click on the connection managers and create a new connection manager. You can only do this if the SSIS package is under project deployment mode. If it is under package deployment mode, you cannot even find the connection managers folder underneath that project. By defining the connection manager at the project level, these data sources can be leveraged from multiple packages in the project and can be changed by the DBA later. By creating a connection here, you type the password one time for your connection, and if you ever change any type of connection information, it changes across any packages using that connection. No negative consequences result from doing this. So, generally speaking, it's a great design time practice to use project connection managers if you see yourself using the connections a few times. Now let's see how to use and configure the tasks. Your package would be nothing without tasks. Tasks in the Control Flow tab orchestrate the work that you want to do in the package. For example, one task may copy a file over from a different server, while another task may load the file into a database. To use a task, you simply drag and drop it onto the Control Flow tab from the toolbox. A common task that you'll use in this course is the script task because it requires no configuration, which makes it a great training tool. Let's drag and drop a couple of tasks onto the Control Flow tab. Let's drag and drop the script task, an expression task, and an FTP task. Until the tasks are configured, by double-clicking the task, you may see a yellow warning or a red error indicator on the task. After you configure the task, you can link it to other tasks by using the precedence constraints. Once you click the task, you can see a green arrow that is pointing from the task. This is called the precedence constraint. This precedence constraint controls the execution order of the various tasks in your package, and you can use it by dragging the green arrow to the next task that you want to chain together. You will learn more about these core tasks and the topic of precedence constraints later on in this course. One thing to remember is that you should never keep the default names of your tasks. Instead, you should rename them to something that you can recognize in the log later. It's preferable to name all of your tasks with some 2 or 3 digit qualifier such as SCR for a script task, and then the purpose of the task such as SCR encrypt file or something similar. This name then shows up in your logs when a problem occurs and can also help you self-document your package. Now that we have seen how to add tasks and how to use the precedence constraints, let's explore the package encryption. A package is essentially an XML file behind the scenes. You can right-click on a package and click on View Code, and it will display in XML mode. And as you can imagine, storing secure information inside an XML file could create some security problems. Microsoft solves this issue by encrypting your package by default with your Windows user key, which is a key that protects your Windows user credentials on your PC. Let's go back to the package and see the protection level for this package. Click on Properties, and let's look for the protection level property. By default, it is encrypt sensitive with user key. You can also change it to encrypt sensitive with password. And if you have your package protection level set to encrypt sensitive with user key, that means that all the usernames, passwords, or other sensitive data are locked down with your user credentials. If you were to pass this package to another user, the package's encrypted data would not be visible, and the user would have to retype the secure information such as the login information. And this property is usually one of the top reasons why packages fail in production. For example, let's say your package has sensitive information inside of it to connect to a database. The package would potentially fail when you run the job because it was running under the SQL Server Agent service account and not your user credentials. You can avoid this problem by setting the property to encrypt all with password and simply pass in the password when running the package or scheduling it. So, it's always advisable to have the protection level set to encrypt with password. Let's close this properties window, and let's say the package is ready for execution. Once your package is ready, you can execute it by right-clicking the package and clicking on Execute Package, or you can simply go to the package that you want to execute and click on the Start button. Now let's create a simple package and try to execute it. First, let's drag and drop 2 script tasks onto the control flow. Let's rename these tasks by right-clicking on them, click on Rename, and let's call them SCR Step 1 and SCR Step 2. Now select the Step 1 and drag the green line, which is called a precedence constraint, onto Step 2. This means that Step 2 can only execute after Step 1 executes successfully. Now let's add a connection manager. Right-click in the Connection Manager's pane and click on New OLEDB Connection. In the Configure OLEDB Connection Manager, let's click on New, and let's define the server name and the database that you want to connect to. Let's call SQL Operations and select the database as AdventureWorks 2014. Click on Test Connection and then click on OK. Let's rename the Connection Manager to just say AdventureWorks and remove the instance name. Now let's select the blank white area of the design pane in the Control Flow tab and then go to the Properties window. Let's go to Protection Level and change it to Encrypt All with Password and enter the package password of your choice here. Click on OK, and now this package is protected with a password. Let's close this Properties window and execute this package. Click on Start, and it executes the whole package. And you can see the results in the Progress tab. So far in this course, you've learned what SSIS is, how to install SSIS and the sample databases, what the different SQL Server data tools are, and how to create a new SSIS package. In the next module, you will learn more about the Control Flow tab and all the tasks that are available in that tab.